Hello everyone, welcome back to the channel. Today we are going to talk about something that we use almost every day, the internet. But instead of simply using the internet, we are going to understand what is actually happening behind the scenes. For example, when I open my browser, type google.com and press enter, a web page appears almost immediately. But what happens when pressing enter and seeing that web page? How does my computer find Google? What is DNS? What is an IP address? How does the request travel through my root device and ISPs? What are packets? And how does the server finally sends the web page back to my browser? In this video, we are going to follow the complete journey step by step. And if you are interested in networking, web development, cybersecurity, or ethical hacking, this is very important concept to understand. So let's begin. First, let's ask the simple question. What really happens when we press enter? Imagine I am sitting at my laptop. I open Chrome, type google.com and press enter. From my point of view, it looks like one simple action. But behind that action, many things happen. My browser needs to figure out where Google is located, what is an IP address. My computer needs to communicate through the network. The travels request through different networking device and networks. Eventually, it reaches Google server. The process for the request done by server and the response that we get. Then my browser receives the response and display the web page. So something that looks extremely simple to the user actually involves many different steps. Before we follow those steps, let's first understand what the internet actually is. Sometimes the internet feels like magic. I can be sitting in any part of the world and communicate with server located somewhere else in the world within a second. But the internet isn't magic. The internet is basically millions of network connected together. Your home network connects you to internet service provider. Your ISP connects to other network. Those networks connects to other network. And all of these networks work together to allow device to travel and communicate. So when we are using the internet, we are actually communicating across a huge interconnected network. Now, let's understand the basic idea of internet. Let's introduce the two main character involved in web request. Meet the two main character. The first character is the client. The device is usually the device that we are using. For example, our laptop or a smartphone. The second character is server. The server provides the website or service we are requesting. A server might run a web server and it may also communicate with the database. So we have client on one side, server on other side. The client asks for something, the server processes the request and provides an answer. And this basic client server model is used by almost every website we interact with. Now, let us look at the client server relationship little more closely. Here we have the client and the server. The client could be my laptop. The browser is learning on the laptop. The server could be computer somewhere on the internet running a web application. The basic idea is very simple. Client asks, server answers. For example, my browser might say, give me the home page. The server receives the request, it processes it, and then it sends a response back. So you can think of internet as a giant conversation between a client and server. But how does the browser actually understands the information coming from the server? That's what we are going to see next. The browser, your translator, right? The browser is one of the most important piece in this process. Example includes Chrome, Firefox, Edge, and other web browsers. A website commonly contains technologies such as HTML, CSS, and JavaScript. HTML provides the structure of the web page. CSS controls how the web page looks. JavaScript provide behavior and interaction. The browser receives this resource and interprets them. It then tenders the result on our screen. So when we see a beautiful web page, the browser is doing a lot of work behind the scenes to turn those web resources into what we see. Now there's an important problem. Humans like name, but computer needs addresses. So let's talk about website addresses. When we use internet, we normally remember website's name. For example, chat.openai.com, google.com, youtube.com, or any other domain name. These names are much easier for humans to remember, but computers communicate using numerical network addresses. That's where an IP address comes in. So we think of it like this. Human remembers the name, computer use the IP address to identify the network destination. So when I type a domain name into my browser, something needs to translate that name into an IP address. So what exactly is an IP address? IP address is a network address used to identify a device or network interface. A simple analogy is a house. If I want to send something to your house, I need an address. In the same way, if one computer wants to communicate with another computer over a network, it needs to know where to send the traffic. For an example, IP before address can look like 203.0.113.25. The exact address isn't important for this example. The important concept is devices need address so the network traffic can be delivered to the correct destination. Now, here's something interesting. Not every IP address is directly visible on the internet. Inside a typical home network, we might have several devices. Our phone, our laptop, our smart TV. All of these devices can have private IP address. Example 192.168.1. Something. These are used inside the local network. Then we have the public IP addresses. The public IP is used for communication with the wider internet. So, a simplified example is inside my home, my laptop might have a private IP. My router has a public facing IP. The internets communicate with my network through the public side. The distinction between private and public IP addresses is very important when we start learning networking and security. Now, we know that website have IP address, but when I type google.com, I don't have the IP addresses or I don't type the IP addresses for google.com. So how does the browser find it? Imagine my browser says I know the google.com name, but I don't know its IP address. So the browser needs someone to help. The helper is DNS. DNS stands for Domain Name System. Its job is to help translate a domain name into a IP address. So instead of remembering a long numerical address, I can simply remember google.com, right? Let's make the concept even easier using a phone book example. Think about the contacts in your phone. You probably don't remember everyone's phone number. Instead, you say mom, dad, friends. So when you select a person's name, your phone knows which phone number belongs to the contact. DNS works with a similar concept. We give it a domain name, for example, google.com. DNS helps provide the corresponding IP address. Then the browser know where it needs to send the request. And this is why DNS is often described as an internet's phone book. One important point, DNS helps find the destination. It doesn't carry the entire web page itself. So that's it. And there's another optimization that makes DNS look faster. DNS caching. Your browser don't necessarily need to access a DNS server from scratch every time. DNS information can be cached at different level. We can have browser caching, operating system caching, router caching, DNS resolver caching, and eventually authoritative DNS server. So if the answer is already cached, the system may be able to use that answer immediately. This saves time and reduce unnecessary DNS queries. So caching is one of the most important reasons repeated connection can be faster. Okay, now our computer knows where it wants to go. But how does the traffic actually leave our home network? Inside our home, we might have several devices: a phone, laptop, smart TV, gaming console. All of these devices communicated through the local network. The router is responsible for forwarding traffic between our local network and other networks. So when my laptop want to communicate with server on the internet, the traffic is sent through the router. The router looks at the traffic and determine where it should be forwarded next. But router alone doesn't connect us to the internet. That's where ISP come. ISP stands for Internet Service Provider. Your ISP provides the connection between your home network and wider internet. So our simplified path is laptop, router, then ISP, then the wider internet. The physical connection might use fiber cables or other technologies from the ISP. ISP enters larger network and eventually reach the destination. So as the ISP act as important bridge between a local and internet network. Now here's an important question. Does the entire file travel across the internet as a huge piece? No. Data sent across a network is broken into smaller pieces called packets. Imagine we have a large file. Instead of sending that entire file as a one giant block, networking can divide it into smaller packets. Example, packet 1, packet 2, packet 3, packet 4. These packets can travel across the network towards the destination. This makes it possible for networks to efficiently handle many different communication at the same time. Let's follow one of these packets journey. Imagine our laptop want to communicate with a Google server. The packet leaves the laptop. It reaches the router. The router forwards it towards the IPs. From then it travels through the internet. Eventually it reaches the destination server. Then the response travel back towards our laptop. So the important data is packet travel from client towards the server and response data travels back towards the client. But what happen if our packet get lost? Let's imagine packet 1 arrive, packet 2 arrive, but packet 3 doesn't arrive. With TCP, the communication can use acknowledgements and retransmission mechanism to provide reliable delivery. If the required data is missing, it can be sent again. That's why TCP is considered a reliable transported protocol. So the simple idea to remember is TCP focus on reliable delivery. It helps make sure that the data arrives correctly and in the expected order. But not every problem wants reliability, or not every application wants reliability at a cost of additional overhead. That's where UDP come in. UDP fast, no confirmation. UDP takes a different approach. UDP does not provide the same acknowledgement and retransmission mechanism as TCP. Instead, it prioritizes speed and lower latency. This can be useful in situations where receiving information quickly is more important than retransmitting every missing pieces. Examples can include gaming, streaming, and real-time voice or video communication. So remember the basic comparison. TCP reliability, UDP speed and lower latency. Neither is simply better. They are designed for different requirements. Now we know how traffic travels between machines. But once traffic reaches a computer, how does it know which server should receive it? Let's use an apartment building analogy. Imagine the IP address is the address of the building, but inside the building there are many different doors. The port number is like the door number. Different service commonly uses different ports. Example, port 80 tends to HTTP, port 443 to HTTPS, port 22 for SSH, port 53 for DNS, port 3306 commonly MySQL. The IP address helps identify the destination host. The port helps identify the service or communication endpoint. This is also why port scanning is an important technique in network security. Now we have reached the web server. Let's see what actually happens when the browser requests a web page. Now our browser can communicate with the web server. The browser sends a request. For example, get request. This basically means please give me the home page. The server receives the request. It processes the request. Then it sends a response back. The response can contain resources such as HTML, CSS, and JavaScript. The browser receives those resources and uses them to build the web page. So the basic relationship is the browser acts, the server responds, right? HTTP provide different method for communicating with the server. Here we have some common HTTP method. Get, commonly used to retrieve data. Post, commonly used to submit or create data. Put, can be used to update data. Delete, can be used to remove data. But one important thing to understand is that HTTP method itself doesn't automatically give permission. The server and application decides whether an operation is allowed. So using post doesn't automatically mean an action is authorized. The application must still enforce proper access control. Now moving forward, let's look inside an actual HTTP request. Here we have a simple HTTP request. First we have get slash login HTTP 1.1. This tells the server that we are using get and requesting the login resource. Then we have the host header. This tells the server which website we are contacting. Then we have the user agent. This provides information about client such as browser or application. And then we have a cookie. Cookie can contain information associated with the session, right? HTTP headers provide additional information that travels with request. When you are doing web security testing, understand this header can help you move forward so easily, so effectively, and you will better know understanding these headers is extremely important part of web security testing. After receiving the request, the server needs to tell the browser what happens, right? This is where a HTTP status method come in, or we can say HTTP status codes. A 200 OK generally means the request was successful. A 302 redirect means the server is redirecting the client somewhere else. A 404 not found means the request resources wasn't found. And a 500 server error means there was a problem processing the request on server side. So status code provides information about the result on HTTP request. So when you are testing an application, these status codes are also very useful for understanding how the server behaves, right? So now we have seen normal HTTP communication, but what about sensitive information like usernames and passwords? That's where HTTPS becomes important. Imagine you are sitting in a coffee shop using your public Wi-Fi. You log into website and send sensitive information. You don't want other people on the network to simply read that information. HTTPS provide encryption for HTTP communication using TLS. With HTTPS, the application data is protected while traveling across the network. So instead of sending readable application data across the network, the communication is encrypted. This is one of the major difference between plain HTTP and HTTPS. But before HTTPS can securely exchange application data, there is an important process called TLS handshake. The TLS handshake happen when the client and server establish a secure communication. The browser starts by sending a client hello. The server responds with a server hello. The server also provides a certificate. The TLS protocol then establishes the cryptographic parameter and keys needed for secure connection. Once the handshake is complete, the client and server can exchange application data through the encrypted channel. So the simple idea is TLS creates the secure channel before protected application data is exchanged. Now let's talk about something we have probably seen many times in your browser. Cookies. Cookies are a small piece of information that a website can ask the browser to store. For example, the server can send a set cookie header. The browser stores the cookie. Then on a future request, the browser may send the cookie back to the server. The server can use that information to recognize the browser or associate the request with some state. That's one reason website can remember things between requests. Cookies are closely related to another important concept known as session. HTTP requests are independent by default. Imagine if every time you click a new page, the website asks you to log in again. That will be extremely inconvenient. Session solve this problem. When you log in, the server creates a session. The browser receives a session identifier commonly stored in a cookie. Then future request includes the session information. The server recognize the session and know that this request belong to the same logged in user. So instead of logging in again and again, home works, profile works, setting works, dashboard works. That's the basic idea behind the session. Now let's look at another technology that helps website load faster. CDNs, also known as content delivery network. The idea is to place cached content on a server in different geographic locations. Instead of every user always requesting content from one origin server, a user may receive cached content from a nearby CDN server. This can improve loading speed, it can reduce latency, and can help application handle a large number of users. Thus, a simple idea is CDNs bring content closer to the users. Now, we have traffic moving through the internet, but we also need security controls to help protect servers, that is, firewall. A firewall is designed to protect filter network traffic. A network firewall can make decision based on things such as IP address, ports, and protocols. Then we have a web application firewall, commonly called as WAF. WAF focus on web traffic such as HTTP and HTTPS requests. It can inspect requests and apply security rules. So we can simplify this into two categories on these slides, known as network firewall and web application firewall. Both helps control unwanted traffic, but they operate with different type of visibility and rules. Let's look at how multiple devices inside our home can share a public address. You can see net network address translator. Imagine my home has five devices. My phone has one private IP, my laptop has another, my smart has another, my console has another, and my printer has another. But when this device access the internet, the outside world can see the public IP associated with my network. This is where NAT comes in. NAT allow multiple devices using private IP addresses to communicate through a shared public IP address. So inside the home we have multiple private addresses. Outside the network, the internet see the public facing address. Now, as we have covered every major steps, let's put the entire journey together. This is probably the most important slide in this entire presentation. Let's go through your complete journey. I start by typing google.com. First, the browser handles the request. DNS helps find the IP address. Destination is identified. Traffic goes through the router. Traffic connects towards the ISP. Traffic travel across the internet. It eventually reaches the destination. Security controls such as firewall can filter traffic. The server receives and processes the request. The server sends an HTTP response. Browser receives that response. And finally, browser renders the web page. So remember the complete flow. It's keyboard, browser, DNS, IP address, router, ISP, internet, firewall, server, HTTP response, browser, and web page. What looks like a single action to us actually involves many different technology working together. And this is where all of this especially becomes interesting for cybersecurity. If you are an ethical hacker, you don't just look at the final web page. You look at the entire communication process. At the browser application layer, we may encounter vulnerabilities such as accesses. At the DNS layer, there can be DNS related security issue. At the network layer, we need to consider attacks involving traffic interception. At the web server and application layer, vulnerabilities such as SQL injection may exist. Authentication can be implemented incorrectly. Cookies and sessions can be impromptly protected. Cookies and sessions can be impromptly protected, and APIs can have broken access control. The important lesson is this: every step in the communication chain can potentially introduce security risks. That's why understanding how the internet works is one of the foundations of ethical hacking and application security. So, let's finish by summarizing everything we have learned. Internet is a collection of connected networks. Browser sends requests. DNS translates domain name into IP address. IP address identify network destination. Routers forward traffic. ISPs connect our network to wider internet. Packets carry data across the network. TCP and UDP provide different approaches to transporting data. Ports identify service. HTTP powers web communication. HTTPS protects HTTP traffic with TLS. Cookies and session helps website maintain state. Firewalls filter traffic. And ethical hacker need to understand every step before they can probably test an application or network properly. So the next time you type a website into your browser and press enter, remember there's a lot happening behind the simple action. You are not just opening a web page, you are starting a journey across the internet. If you are learning web networking, ethical hacking, understanding this fundamental will make the advanced topic much easier. In the next videos, we will take this concept further and start looking at security side of web application. Thank you for watching. I will see you in the next video. Thank you.